You're listening to DTFHN for August 18th, 2026. I'm your locked room escaped host, Jack Haxman. We are your daily tech feed for Hacker News, a website W section files better bug reports than the QA department. Today is about the gate always being flimsier than the thing it was guarding, and about who bothers to walk through it. Let's pick the lock. In 1910 was Rebel 3.8 ungrabble as OA traft evet twinebook. Crashes, stutter, a slideshow, which is strange because overcommit has existed in GPU drivers the whole time. Ask for more vRAM than the card has, and the driver gives it to you, spilling the overflow into system memory. The mechanism was always there. It just performed badly enough that everyone treated the limit as physical rather than economic. A developer at Pixel Cluster spent months pushing patches through kernel mailing lists. And there, merged for Linux 7.3. What's worth stealing from that post is the arithmetic, because it strips the marketing off the whole conversation. PCIe 4.0 by 16 gives you a shade under 32 gigabytes per second. Per millisecond, that's about 32 megabytes. A 30 FPS frame is 33 milliseconds. Multiply it out. Roughly 1 gigabyte of evicted memory the GPU can touch in a single frame before 30 FPS becomes physically impossible. Not unlikely. Impossible. That's the budget. Everything else is engineering inside it. And here's the part that reframes the problem. Not all memory is equal. Drivers already park command buffers in system RAM while vRAM sits half empty, and nothing burns down because cache absorbs the latency. The microbenchmarks show it plainly. Under 6 megabytes on RDNA3. The L2 size system memory and vRAM have identical access latency. Identical. The bus costs only bytes when you miss cache. So the real question was never, how much vRAM do you have? It's, which bytes get touched every frame? And are those the ones you kept? That's a scheduling problem, not a hardware problem. And it's the kind of problem you can only fix if you can read the driver, patch the driver, and argue about the patch in public for 8 months with people who disagree with you. One commenter noted that games ship enormous piles of textures that are barely sampled. They're right, and that's the next gigabyte. Somebody's already thinking about it. That's how this works. 8 months of public argument to reclaim a gigabyte of texture memory. Story 2 takes that same energy and points it at something even more entrenched. When how we write database code. I built a pipeline once where every stage returned a slightly different shape, and the bugs didn't show up in any stage. They showed up in the seams between them. That's the exact wound this project is poking at. The article is about a language that compiles to a SQL, not a wrapper, not an ORM stapled onto your objects. A real language with some types, reusable functions, and pipelines that flatten down into queries your database already knows how to run. Think of it the way a luthier thinks about a violin. The strings make the sound, but the body is what makes it carry. SQL is the strings. Everything the last 40 years bolted on around SQL. The string concatenation, the query builders, the 12-layer abstraction that generates a where clause you can't read. That's a body built by committee, and it rattles. The craft here is in the compilation. When you write a function in this thing and call it 3 times, you don't get 3 round trips. You get 1 query, because the compiler knows the difference between composition in your source and composition in the execution plan. Some types are the sharp part. SQL has no native way to say this column is either a shipping address or a pickup location. Never both. And here's what each one carries. So you fake it with nullable columns and a discriminator, and a comment begging future you not to break the invariant. Giving that a first-class encoding is genuinely good engineering. And one commenter puts their finger right on the cost. Custom binary encoding for some types means your other tools can't read those columns. Coexist with SQL starts looking optimistic. That's a real tension, not a gotcha. Another asks whether a one-line query is now 6 lines. Sometimes, yes. The trade is legibility at scale versus terseness at small. Another wanted a replacement for PLSQL. Stored procedures, the thing every vendor implemented incompatibly to make sure you never leave. That's the version of this problem I'd most like solved. And it's telling that the vendors never did. What matters is that this exists in the open, where you can read the compiler and see exactly what SQL comes out the other side. A closed version of this would be a lock-in machine. An open one is just a better tool. Go try it on a side project. Now for something completely different and completely delightful. How Bluesky draws its own logo onto screenshots. Story 3. Every screenshot you take is a claim about what was on a screen. On iOS, that claim is negotiable. Tim Morenin noticed a Bluesky logo in the corner of a screenshot. A logo that isn't there when you're looking at the app. In the live interface, that spot holds a follow button. Screenshot it, and the button vanishes, and the butterfly appears. Screenshot mid-app switch, and the button stays. That inconsistency is the tell. Because the app is open source, the answer took one search. A file named growthhack.tsx, added in January, leaning on a package called Expo Privacy Sensitive. Here's the mechanism. iOS gives you a text field with secure entry. The password box. Its contract is simple. When the system captures the screen, that layer goes blank. So, you create a secure text field you never intend to hold a password. Render your follow button into its layer and put the logo underneath. The system blanks the button on capture. The logo shows through. It was always there. The app switcher case falls out of the same constraint. iOS snapshots your view when the gesture starts, and that snapshot is a dead image. No live text field, nothing to blank. You screenshot a photograph of a moment before the trick fired. This is old technique. Telegram uses it for secret chats. Signal uses it. It's load-bearing for privacy features Apple isn't going to break, which means the Growth Hack version is permanently safe by association. Now apply the test. Notice what actually happened here. Someone got curious, read the source, found the file, and published the mechanism inside an afternoon. The name of the file is Growth Hack. Nobody had to reverse engineer intent, because the intent was checked into the repo. The pull request thread argued about whether this was cute or an abuse of a privacy API. And then got lock, which tells you where that landed. Run the same story on a closed client. The behavior is identical. The file name is identical, and you get nothing. You notice a logo. You can't reproduce it reliably, and you're left writing a blog post that ends in a shrug. One commenter said, "The real problem is that the OS permits any of this. That a screenshot should be exactly what was on the glass. Reasonable position. But the API isn't going anywhere, so the practical question is which apps you can audit. That answer's architectural, and it's already public." That's the fun of a day like today. One story ends in a shrug. The next one hands you a 50% price cut. Story 4. One commenter asks a very reasonable question. Where is the official source? OpenAI's own docs still list the old price. The cut is visible on OpenRouter, an aggregator, which means the first place you learn what a closed model costs is not from the company that made it. That's the state of price discovery in this market. Somebody noticed the meter move. Another commenter says, and I quote, "This looks like a race to the bottom, and I love it. Let's take that seriously. Follow the principle all the way down. If inference pricing is a race to the bottom is caught. Electricity, silicon, amortized training. Below that, you're buying market share, not selling compute. So run it forward. Prices fall until the only thing separating providers is who can eat losses longest. That's not a technology competition anymore. That's a balance sheet competition. And the funny part, the genuinely funny part, is that the thing forcing the pace isn't another lab with a war chest. It's the open weights. First comment in the thread says it plainly. Thanks to the Chinese open models, US big players have to cut their inference pricing. They ran their own evals. Kimi K3 came out on top for their workload. Nobody had to take that on faith, because the weights are downloadable and the benchmark is your own laptop. Think about what that does to a price list. When the alternative is a closed API, you can't inspect the vendor sets the number and you accept it. When the alternative is a model, you can host yourself. The vendor's number has a ceiling, and the ceiling is what it costs you to run the open one. Open weights don't have to win the benchmark to win the negotiation. They just have to exist and be good enough. 50% off is what that pressure looks like on a receipt. One more comment worth sitting with. Someone switched off Claude for coding. Says the competing tool caught up, more value for the money. That's a person doing the thing the whole architecture is supposed to enable. Switching cost is the real product in this business, and it's currently low. Keep it low. The models getting cheaper is good. The reason they're getting cheaper is better. 1,000 people publishing weights moved a price that 100 people in a room could not. The tools exist. Go check the eval yourself. Switching costs stayed low in that story. Now, what happens when a company dies and its data goes up for auction? Story 5. Google buys Spirit. Every word of that holds up. And it still misses the thing that matters, because the objection was never that the data got used. It's who got to bid. 2 parties showed up, Google and Mercor. A company whose entire business is selling training data to AI labs. That's the market. A liquidation auction with a bidder list you could fit in an elevator, and a clearing price of $10 million for the operational memory of an entire airline. 10 million is a rounding error at Google. It's insurmountable for a university aviation safety program, for the mechanics union, for the 4,000 people who worked there and generated every one of those fuel slips. I am not asking for less copying. Copying is how knowledge compounds. I'm asking why the compounding happens inside exactly one company's walls. This data is about to be enclosed harder than it ever was under Spirit. Not because of a law, but because a private buyer paid for exclusivity and the bankruptcy process handed it over as a clean transfer of title. The flights happened in public airspace. The safety lessons in those 600,000 tickets are lessons every carrier should have. There is a version of this that isn't hypothetical. Liquidation is a one moment when a dead company's data has no owner with an interest in hoarding it. De-identify it, publish it, let Google train on it, and let everyone else train on it too. The trustee still gets paid. Auction the compute contract, not the exclusivity. Instead, one bidder, one copy, one lock. Fasten your seat belts. So, how does a company's data die in a vault of pause, and how does a 1996 CD-ROM survive precisely because ID Software crammed it too full to lock down? Story 6. 39 Ds. That's how long it took a group called GameGnomen to publish a tool that decrypted every single game on the Quake Shareware CD-ROM. Not one game. All of them. The entire lined software catalog sitting right there on a disk you could buy at CompUSA for $9.95. Here's what it was actually attempting, and it's more interesting than copy protection failed. 1996. CD-ROMs held 640 megabytes. Quake Shareware used 22. Carmack had joked 2 years earlier that a CD version of Doom would have to ship with a feature-length documentary just to fill the space. So id looked at that 618 megabytes of dead capacity and had a genuinely good idea. Put the whole catalog on there, encrypted. You buy the disk. You like a game. You call 1-800-ID-GAMES. Read off a credit card. Get a code back, and the game unlocks. No shipping, no retailer margin, no waiting. That's digital distribution. Uberzor? 1996. Over a phone line, running on physical plastic, but architecturally, that is Steam. A decade before Steam, the insight was exactly right. The bottleneck isn't the bits. It's the permission layer wrapped around them. And the permission layer is the part that broke. The retail experiment collapsed so completely that ID ended up with roughly 150,000 unsold CDs in a warehouse. Order fulfillment spun out of control. The crack circulated. Kushner writes about it in Masters of Doom as a disaster. But run this forward. The bits shipped. Every one of those disks delivered the full catalog into someone's hands at the speed of light through plastic. And the only thing that failed was the gate. One commenter on this piece says the files in their ID1 directory, the ones they've carried computer to computer for 30 years, came off that disk when they were a broke teenager. 30 years of continuous use, from a distribution model that supposedly failed. The thing that got right was radical, and they got it right first. Put everything in front of everyone. Remove the middleman, let the artifact travel. The thing that failed was the encryption wrapper, and Carmack, of all people, went on to open source the Quake engine in 1999. Which is why Quake still runs on hardware that didn't exist when it shipped, on ports maintained by people who were toddlers in 1996. The catalog outlived the lock. It usually does. Moving on. 40 birds ranked. And the detail that gives the whole project away is buried in the methodology. The author throws out the fire-fronted Sarin. Great bird. Tiny finch. And its forehead is a genuinely incandescent orange. Bright enough that its plumage sample sits outside what your monitor can physically show you. It made the boundary, and it got cut, because the rest of the bird is beige. One spectacular spot on an otherwise unremarkable animal. That's a ranking problem, and it's an old one. This is a color science post that is quietly an information retrieval post. Convex hull, then alpha shapes. Allow concavities up to a size you choose. So, the sparse magenta region of bird color space stops being invisible. Then, chroma from CIEL. So, a brighter green outranks a duller green of the same hue. Every one of those moves has a document ranking twin. The Sarian is keyword stuffing. One term matches perfectly. The document is garbage, and the naive scorer loves it. Salton and the Smart System were fighting this at Cornell in the 1960s. And the fix then is the fix now. Stop scoring the best match and start scoring the whole object. What I like is that the author says out loud in the first few paragraphs that this is subjective math, not objective. Subjective made explicit, then implemented. That's a rarer thing than it sounds. Most ranking systems in the world right now are exactly this. Someone's aesthetic preferences converted into a loss function. And almost none of them publish the preferences. Your feed is ranked by a chroma function nobody will show you. This person shows you the whole pipeline. Spectrum to CIEX to Keylab to LCH with the empirical human eye constants right there. You can disagree with the alpha parameter. You can go rederive it, and the underlying data is bird color based. Spectrophotometer readings of actual feathers collected by people who went and measured birds. Open data, someone's obsessive weekend, a top 40 list. That's the whole bootstrap in miniature. One commenter's complaint. The page is unreadable. Charts need 200% zoom, at which point the body text becomes enormous, which is a small, funny coda to a post about the limits of display. The author found birds whose colors literally cannot be rendered on your screen. Colors outside DAS RGB, outside display P3, that no monitor you own can produce. Turns out the harder rendering problem was the CSS. Colors your monitor can't render, and now a phone camera that finally can pause the Fairphone 6 has a working main camera on PostmarketOS. What is the smallest thing a phone has to do before you're allowed to depend on it? Not run apps, not take photos. The floor is lower and much harder than that. And almost nobody building alternative phone operating systems talks about it out loud. Start with the camera, because the camera is the craft. A developer at CatCrafts has written the main camera driver for the Fairphone 6 running PostmarketOS. Mainline Linux on a phone you can buy, building on earlier work someone else did on the wide lens. Autofocus works. Color correction is in, and the before and after is genuinely striking. The raw sensor output looks like a photograph of a photograph left in a window, and the corrected version looks like a picture. It's still grainy. The developer says so plainly. Notes that Plasma's camera app writing straight to JPEG isn't helping, and then does the thing that separates engineers from marketers. Puts the shot side by side with the same scene from a Galaxy A16 and says there's a lot of work to be done. That comparison is the whole personality of the project. Nobody made him publish the frame he loses on. And the mechanism of how this spreads is beautiful. He asked the other developer what role he wanted in upstreaming, and they agreed. The other person submits. He reviews and assists. Then he writes, and I quote, that he successfully pulled down another soul into the Linux phone kernel rabbit hole. That's how a driver ecosystem actually grows, not a roadmap. One person handing another the harder, more visible job. Now the question everyone was avoiding. Every image this project ships carries a warning that emergency calling is unverified, so he tried to verify it. Searched, found nothing public, and eventually just called the police non-emergency line and explained what he was doing. The operator said the process isn't public, but gave him an email address. He assumed the answer would be that this is for big tech only. The Dutch National 11A Technical Management Office wrote back and approved a test window. A single independent developer, on a mainline Linux phone, got a scheduled slot to confirm he can reach emergency services. Think about what that resolves. Not a technical problem. A legitimacy problem. The gate was never sealed, it was just unmarked, and everyone assumed. He's also publishing his finances as a live page generated from his bank statement, and moving toward a non-profit structure with a publicly visible salary, working code, open books, and a phone that can call for help. From a phone that can call for help to a game about sinking putts. What happens when a developer builds the thing they wish existed? In 2000, Sports Interactive and Eidos separated. Eidos kept the name Championship Manager. Sports Interactive kept the people, the code, and the database. 12 years of scouted player records built by volunteers. The next year, both Championship Manager 5 had the brand and sold poorly. Football Manager 2000 Victon had the engine and became the franchise. The name was the asset everyone could see. The simulation was the asset that mattered. Which brings us to a browser game about golf. One developer, no publisher, no license, no player likenesses, explicitly modeled on Basketball GM. You manage a career, tournaments, form, aging, the slow arithmetic of a pro's decade. Let me argue the other side because it's the obvious argument. This should not work. Sports sims are a licensing business. The reason people buy the football game is the badge on the shirt, and the reason the incumbent charges $60 a year is that it holds the exclusive rights. A solo developer has none of that, and golf is the worst possible pick. Individual sport, no roster to assemble, no trades, no draft. You have removed every management verb from a management game. That argument is coherent and it's wrong, for a reason golf makes unusually clear. What you're actually managing is a probability distribution over 4 rounds. A player has a skill vector. Driving, approach, putting, scrambling, and each round samples from it. Career management is deciding which distributions to invest in while the whole vector decays with age. That's the entire genre in one sentence, and it requires 0 licensing to build. The incumbent's exclusivity protects the badge. It doesn't protect the math. Basketball GM, the acknowledged model here, is GPL licensed and public. Its author has spent over a decade shipping a free browser game with the source open, and the direct result is that someone read it and built golf. That's the whole mechanism. A working engine placed where others can reach it, and the genre widens by one sport at no cost to anyone. The one substantive comment is a bug report. Achievements unlocking for requirements the player didn't meet. Congratulations on something you didn't do. It's a small defect, and it's the most informative detail available, because it means this is running in front of real users who found the edge cases within days. A shipped game with a wrong achievement flag is further along than a correct design document. The tools exist. Someone read the source and made a golf game out of it. Now, DuckDB v 0 is in preview, and the changelog is a joy to read. The first thing I look for in any system I'm asked to reason about is which constraints are real and which ones are just the shape of an old decision nobody revisited. DuckDB spent 6 years as an in-process database, embedded, no server, no network, no daemon. That was the identity, and the whole time underneath it there was full MBCC and transaction isolation sitting there doing nothing. Because a single user on a single laptop never needs to be isolated from anyone. Version 2 ships this fall, named after a cinnamon teal. 10,000 commits since March. And the headline is that they finally caved. DuckDB can now be a server. Strip it at first principles. What does a client-server database actually require? A wire protocol. Concurrency control, a way to point a session at a remote and get results back. DuckDB had 2 of the 3 already built and idle. What shipped is the Quake extension. Any DuckDB serves its databases over the network. Any other DuckDB attaches and routes queries there with a new connect statement. And connect isn't limited to DuckDB talking to itself. Point it at PostgreSQL, and the new pushdown optimizer ships your SQL to the Postgres server instead of dragging the table across the wire to you. Here's the part I keep turning over. The authors say plainly that they built this so DuckDB could talk to other DuckDBs. Within weeks of the preview, people had written standalone clients for the protocol. Their words: "We thought we were extending DuckDB to talk to other DuckDBs." The world said no, 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 and built their own clients. That's not a surprise. That's the mechanism. An open protocol in an MIT licensed database is a public specification whether you meant it as one or not. You cannot ship a documented wire format to 100,000 engineers and then decide what it's for. The intended use is a suggestion. The protocol is the product. One commenter looks at 10,000 commits in under 6 months and asks whether AI wrote them. Probably some. Good. That's the tooling working. A small team moving at a scale that used to require a large one, and the output is a database anyone can read, fork, and now build clients for. Another commenter just wants 4 GUI clients editing one database concurrently. Modest with a knob and scythe. As of this fall, that's a 2-line answer. This has been your daily tech feed for Hacker News for August 18th, 2026. This podcast is entirely AI-generated. Scripts by Claude Sonnet 4.7. Voiced by Quen3 TTS. Not affiliated with Hacker News or Y Combinator. Now go read the source on something you use every single day. We'll see you back here tomorrow.